Okay, today we're going over section 2.3, which is the applications of algebra. So it's kind of working with word problems. We're going to translate verbal statements into algebraic expressions and use problem-solving procedures. But before we get there, we have a bell ringer and we have a little quiz today. So we're going to do bell ringer and quiz review. So I want you to work through your bell ringer on your sheet. And then I'll leave this slide up, and you want to work through these on your whiteboard because these are not on your sheet, okay? So pause the video, and then we'll go back to the other slide and work through the bell ringer and then the quiz review. Okay, so first one, we're doing an order of operations type thing. So the first thing we do is we take care of these exponents, all right? So that would make that a 9, that'd make this a 16. Negative stays in front, okay? Absolute value, we can kind of do that one if we want to as well. So 3 minus 4, that gets us a -1 in there. And then that 6 squared. Okay, so remember that negative is not going to be squared because the 6 is the only thing with the square. So that negative or that subtraction stays as a subtraction, and we have 36. Okay, so next thing, take care of the 9 plus 16. That negative stays in front. We got a 25 there. Absolute value of -1, we'll change that to a +1, and then that minus 36 is still back there. Okay, then root 25, we're going to take care of that next. So that turns into a -5 plus 1 minus 36, and then we just go from left to right. So -5 plus 1 is -4, minus 36 is a -40. All right, so 2, we are just going to evaluate this. So we're going to plug in -2 for A, 3 for B. And when you plug things in, you want to put them inside of parentheses. Okay, that's our -2. Minus 3 times -2 squared times B, which is 3. And then we got this one, so plus 3, A is -2. B is a 3 squared, and then minus 3 to the third on the back. So cubes do not get rid of the negative, so that stays as -8. And I'm going to kind of take care of these inside here, then we'll just multiply that whole crew there. So that would turn this into a 4. So then we got 3 times 4 times 3. So that's 3 times 4 is 12, times 3 is 36. So it's minus 36. Let's do the same thing here. So that turns into a 9. So 3 times -2 is -6, times 9 is -54. And then back here, 3 cubed. Remember the negative is away from the cubed. So that would be a 27. And then we just go from left to right, kind of add things as we go. So -8 minus 36 is -44. Minus 54 is -98. Minus 27 is -125. All right, and we got this one down here. Solve for y. So there was a trick to getting rid of fractions that I told you last time we had class, okay? So we look at the denominators, the 2 and the 3, and we look to see how we can get rid of those by multiplying by a common denominator. So between 2 and 3, we would multiply by 6, okay? And so remember, people didn't like the cross-canceling stuff very much, so we just multiply those top numbers by the 6, and remember, put this over 1, and that's the top number still. So this is 6 over 2y plus 12 over 3x equals 6 times 4 is 24 over 1. We can just leave it as a 24. And then we reduce these. So 6 over 2 is a 3, 12 over 3 is a 4. And then we have the 24 there. And now we're looking to get the y by itself right there. So we got to figure out how we can move everything around. So addition, subtraction moves around first for solving. We do PEMDAS backwards. So the 4x is going over. Okay, these aren't like terms, so we can't put them together. We just write them both out. All right, so we have 3y equals -4x. You want to write the x term first. It's a good habit. Okay, and now we divide everything by 3. And then that'll go away. We have a -4/3 x, and then 24 over 3, that is an 8. And we have this, y equals -4/3 x plus 8. Okay? So we had a few more that we're going to practice here. So very similar. We got to take care of fractions. We got to distribute, and we got to solve for certain things. So on the first one, we're looking at the denominators again, 2 and 3 and 2. So between those three numbers, we'll have a 6 again. So 6 over 1, multiply them top numbers by 6. So 6 over 2, 12 over 3, and then that's a 30 over 2. Okay, and then you reduce them. So 6 over 2 is a 3x plus 12 over 3, which is a 4. 30 over 2, that is a 15. And then we just work to get the x by itself. So move this over by subtracting 4. And we get an 11. Okay, 15 minus 4 is 11. Divide by 3 on both sides. And we get x equals 11 thirds. You want to maintain the fractions. Okay, don't put that in your calculator, because you're going to be rounding it off, okay? Next one, so we have a distributive property thing going on here. So you could get rid of fractions first, or you could look a little bit further ahead and say, if I distributed this, that 1/3 is actually going to turn into a nice number with these two, okay? Because 1/3 and 3, that's just a 1. So it's better off just to distribute right away. So that's 8x minus 6. Distribute the 1/3. So 1/3 times 3x is just an x. 1/3 times 6, that is a 2. And then we just work to get the x by itself. So put the x's on the same side. Those are gone. So I have 7x minus 6 equals 2. Put the constants together. So those are out of here. And we got 7x equals 8. And then divide by 7. And we get x equals 8/7. And again, leave that as a fraction, okay? Mixed numbers, we don't want those either. You just want to work with improper fractions, okay? So you don't want that. You don't need 1 and 1/7. Just leave it as 8/7. That's easiest. Okay, next one. Another one that says solve for y, and this one should be a little bit simpler than the last one. Okay, we don't have any fractions, so there's no fractions to clear out, so we just need to move things away from the y. So 2x is going over. We get 3y equals, again, you want to write the x first. Negative 2x plus 6. Then divide everything by 3. Okay? And there's a couple ways that I showed you last class that you could have an answer. This is one way. You could do this, but when we start working with linear functions and writing mx plus b, you want to split those, okay? So it's y equals negative 2/3 x, because we're taking both of these and putting them over 3, so 6 over 3 is a 2, okay? Either one of these answers will work, but this one is the best, okay? So now, I want you to work through the quiz. So please pause the video and work through the quiz, and then start the video up, and we'll get rolling with the lesson. Okay, so writing words into math. That's what we're working with today. Okay, writing phrases into algebraic expression. There's some examples on your notes. Okay, they might be kind of small, but these might be kind of helpful. The ones that people make mistakes on the most would be like something like this, 7 less than a number, okay? Because people are just thinking, oh, 7 minus x, because x is the number, but that's actually backwards, okay? So this one would be another one that's kind of like that, where people might make mistakes, okay? So like A, right away, 6 less than 3 times the length x. All right, so we're calling x the length, and we want 6 less than that. If it's kind of hard for you to figure this out and think about if I'm going to write 6 minus x or x minus 6, just put a number down and then kind of go from there. So let's say our length is 12, okay? And we want 6 less than 3 times 12. So it's like, all right, 3 times 12, that makes that a 36. We want 6 less. Oh, okay, we're subtracting 6. That should be how we write it. Right, so it'd be 3 times x minus 6, because we're subtracting 6 from it. Okay? People like to read it and then just write things down. So if we're just reading it, you'd be like 6 minus 3x, but that's backwards, okay? So be careful on these ones, okay? B, the cost C of an item is increased by 23%, all right? So we're adding 23% of that cost. So we have to think about how we use 23% first of all. So using a decimal in a formula would be 0.23 for this case. You move the decimal twice, okay? 23% is 0.23. And if we're adding 23% to something, we have to take 23% of that cost already. So it would be cost increased by 23% of the item's cost. All right, this would be a 23% increase on that item. Similar, say you're going to shop at Kohl's, you want to find what your discount is. Let's say they like to do a 30% discount all the time. So if I want to figure out what the cost of my item is going to be with the discount, it'd be cost minus 0.3 of the item. And then that would give me my cost, all right? So this would be like a 30% discount, okay? I know they always have the little tags with all the different percentages and stuff on there, but me being the math guy, I like to check to make sure they're right. Make sure I'm getting my full 30% off. Might want to be something that you do in the future. Checking other people's math is very helpful sometimes. Okay, so C, the length of a rectangle is 5 units less than 4 times its width. Okay, so length of the rectangle is 5 units less than 4 times its width. So we're comparing things to the width, all right? And we could say length equals 5 units less, and there's that less again, that might mess us up, 5 units less than 4 times its width. So 4w minus 5. So the length is 5 units less than 4 times its width. Okay? So whenever you see is, all right there, that generally means you're going to make an equation or you're comparing two different variables. Okay? So is for equals. D, the cost of renting an iPad for X days is $15 per day, or at $15 per day is $120. Okay? So X days, we don't know how many days we're going to use, $15 per day. So per means we're going to multiply something usually, because that's a rate. So $15 per day is $120. And we could actually take this and solve for how many days we had the iPad, right? So is, again, that's equals. Okay, so don't forget that one. But it's $15 per day is equal to $120. Okay, so with these, we're going to be seeing some of these things in different questions. So we have to make sure we understand base level of writing basic equations in algebra. All right, now you could sometimes just kind of common sense your way through, but most of the time it's going to say write an equation and then solve. Okay, so just like this, write an equation, solve, writing a clear explanation. Okay, a car used 16 gallons of gasoline and traveled a total distance of 460 miles. The car's fuel efficiency is 30 miles per gallon on the highway and 25 miles per gallon in the city. How many gallons of gasoline were used on the highway? So we used 16 gallons total, traveled a total distance of 460 miles. All right, we went 30 miles on the highway, 30 miles per gallon. That's our efficiency on the highway. 25 miles per gallon in the city. Okay, so with this question, we kind of have to figure out what we want to use first. If we want to use highway miles, if we want to use city miles. So we'll stick with highway miles. So H is just going to be, or highway gallons, okay? All right, so H is going to be number of gallons on the highway. And then we can kind of think about if we are going to use a certain amount of gallons on the highway, then the other one, let's say our city miles, is going to be 16 minus H. So that's number of gallons in the city. Okay, so we kind of have to establish this in the beginning. H is our highway miles, and 16 minus H would be how many gallons, or excuse me, I said miles again, it's gallons. And then 16 minus H would be gallons in the city. All right, with that, then we can kind of make an equation with this and this. We can use our fuel efficiency and our total miles. Okay, so we have 30 miles per gallon on the highway. That's just H. And then we have 25 miles per gallon in the city. And we have to put that 16 minus H in there because those are city gallons. Okay? And then if we had 30 miles per gallon at this many gallons and 25 miles per gallon at this many gallons, that would get us our total distance like that. Okay? And then from here, everything is written with H's, so we can kind of work to solve. So 30H plus 25 times 16, that's 400, minus 25H is equal to 460. And we can keep working to solve. So put the like terms together, 30 minus 25, that's 5H plus 400 equals 460. Subtract that 400 over. Those are out of here. And we get 5H equals 60. H equals, how do we get rid of that 5? You got to divide it. H equals 12. Okay? So that means we went 12 miles, or we used 12 gallons on the highway. Okay, so we used 12 gallons on the highway. And how do we get the other one? Well, we had 16 minus H. So that means we used 4. We used 4 gallons in the city. All right? So when we are solving word problems, we want words in the answer. When we're solving real-world situations, we want to explain our answer in words. Okay, so those are going to be the answers we're looking for. So this was a little tricky. Okay, there is another way to do it, which I think might be slightly better, because this part right here is a little tricky. Okay, so if you started with your equations, 30H plus 25, and we're going to say that that's C for city miles or city gallons, 460. So that's our total miles per gallon and miles we went. And then we knew that we had our highway miles and city miles, or highway gallons and city gallons is 16. So you would have to start with 2 equations like this, and you have to do what's called substitution. So we pick one of these variables to solve for. And what we actually did up here is we were solving for C. Okay, so see how we get 16 minus H again for that. And then you take this C and put it into that C. And then that's where this equation came from. Okay, this might be a little bit more work to start, but I think it makes a little bit more sense because you have 2 equations. One has your miles per gallon in miles, and the other one has total gallons. Okay, either way, if you want to do it this way, that's fine too. So, next question. In 2018, the budget for Seward Public Schools was $4.8 million. The 2018 budget was a 3.2% increase from the 2017 budget. What was the 2017 budget? Okay, so we can say, if we want to think about this a little bit, so 2018 budget is, fix that one there, is 2017 plus a 3% increase. All right, so kind of think about this a little bit before we make an equation. So we know the 2018 budget is 4.8 million, and we're just going to use 4.8. We don't have to put all the zeros there. So 4.8 million, or 4.8, is the budget from 2017, which we don't know. Okay, so we're going to call that X. That's this, plus a 3%. So how do we do percentages again? So this is 3%. we got to move that over twice. So 0.03 times that budget, right? So 2018 budget is the 2017 budget plus 3%. So this is our equation. It was kind of like those discounts and increases that I showed you a couple slides ago, but this is how we solve for our budget. All right. So 4.8 is equal to, so 0.03, this is a 1, so we could do 1.03x, and then solve by dividing by 1.03, and that's gone. And we get x is equal to 4.65. All right. So the 2017 budget was 4.65, and we are in millions. All right. So solve the problem, set up the equation, get our answer, write our answer in words. All right, I want you to read through this one and then see if you can kind of set up an equation here. So you want to maybe you want to write an equation and things that you understand and then start to throw your variables in there, things that you know and things that you don't know. Okay, so read through it and then I'll read through it a little bit and then we'll see how we did. So we're going to a beach, all right? So when we made our hotel reservation, we were quoted a rate of $95 a night before tax. So we have to pay a little bit more because that's before tax. When they checked out, their total bill was $110.85. That included the room tax and a $3.50 charge for a candy bar. Okay, we want to determine the tax rate. So we know we got our $95 for the room. Okay, we got a $3.50 charge on the candy bar, and then there's a room tax. All right, so plus room tax. We have to figure out how to get that. All of that together is $110.85. Okay. Well, you have to kind of understand how taxes work in order to figure out a room tax. So remember, like sales tax, you go to Walmart and you buy a toy or something like that, you're paying a sales tax on the normal price. So this room tax is going to be extra on top of our $95. So that would be $95 times that tax rate, and maybe we'll just call that R. That's how we would write this out, okay? So we got our 95 plus our 350 plus 95R, that's that rate we don't know. All that together is equal to 110.85, okay? So we got to put all this together. So we got 98.50, we can add those two together just because they're constants, plus 95R is equal to 110.85. So move the constants away, so now we're just doing some algebra here. Move that constant away, that 98.50, it's out of here. 9R is equal to 1235, that's what we get when we subtract those, okay? And now we have 9 times R, we have to undo that by division. We got to do the opposite, the inverse. All right, and then we end up getting R is equal to 0.13. So this is our rate, which remember rates are percentages, but when we take our rates or percentages out of our equations, we got to turn it back into a regular percent. So you're moving that decimal place twice. So that is a 13% tax rate. So we can say the room tax rate was 13%. And we have it. Okay, so it might be helpful, like I did here, write everything out, figure out what we're trying to find, figure out how to get that put in terms of like algebra type stuff, and then start working through it. All right? So 5 and 6 are kind of similar because they're working with shapes, and we're trying to find different dimensions of shapes. Okay? We'll work through 5 together, and then I'll have you try 6, and then we can play it for the answer. So, 3 rectangles have a combined area of 130 square meters. The largest rectangle is twice as large as the smallest rectangle, and the third rectangle is 10 square meters larger than the smallest rectangle. Okay? So we got like a small, medium, and a large. Okay, so let's just say small and medium and large rectangle, or maybe you can use a capital L. Okay, all 3 of those have a combined area of 130 square meters. Now we can start using this stuff to start writing this stuff out. So the largest rectangle is twice as large as the smallest. So 2 times the small one, that's the large one. And the third rectangle is 10 meters larger than the smallest rectangle. So the third one, that's our medium one. Okay? It says that one's 10 square meters larger than the smallest one. So we can just say small one plus 10. All right? And you could have used rectangle 1, rectangle 2, rectangle 3. Either way you want to do it. X, Y, Z. Okay? But this is going to be kind of similar to the stuff I did before, where we said we have L is equal to 2S. Well, we got an L there, so we would throw that 2S in there. And M is equal to S plus 10, so we can throw that S plus 10 where that M is, and then we rewrite it. So, and I probably don't need parentheses. We'll just leave them there for now. S plus 10 plus 2S equals 130. So those parentheses just show you that I'm plugging stuff in. So we can just combine like terms from here. So S plus S, that's 2S, plus another 2S, that's 4S, plus 10 is equal to 130. And then, again, algebra here, solve that out. 4S is equal to a 120 divided by 4, and we get S is equal to 30, and this is square meters. So that's our smallest rectangle. So how are we going to get the other ones? We're going to go back over here. So we can plug a 30 in there and a 30 in there to get the other ones. So 2 times 30, that means the large one is 60 square meters. And then this one, 30 plus 10, the medium one is 40 square meters. Okay? So we could say the small rectangle is 30 square meters. The medium rectangle is 40 square meters, and the large rectangle is 60 square meters. And then we have it. Okay, so the next ones are going to be kind of similar to this, where we're comparing 2 other triangles or 2 other something to 1 of something. All right, so let's look at 6, and then we'll finish up. Okay, so we got to remember what complementary and supplementary are. Okay, it was kind of a struggle for me to remember the 2, but then I had a kid in the class that said, well, supplementary, that's supplements. So supplements make you bigger, so this is the bigger one. So this is 180. Okay, complementary, that's 90 degrees. So supplements make you bigger, then complementary, just process of elimination, that's got to be the other one. All right. So if angles A and B are complementary angles and angle B is 58 larger than angle A, determine the measure of both angles. Okay? So since they're complementary, we know that angle A plus angle B has got to be 90 degrees. That would be a given equation, kind of. All right, same thing here. And it says angle B is 58 larger than angle A. So angle B is A plus 58. It's 58 larger than A. All right. Now, what do you think we're going to do with our 2 equations? We got this one's got 2 variables, this one's got 2 variables, but this one's solved for one of them. So we could probably take this stuff and throw it into there, which is what we're going to do. So A is equal to, oops, not equal to. So A plus B, which is that stuff, is equal to 90. And then we got a pretty simple equation to solve. So 2a plus 58 is equal to 90. Move the 58 over. That's out of here. 2a is equal to 32. And then divide the 2 out. A is equal to 16 degrees. That's degrees. Make sure we label it. Okay? But we still need to find B. How are we going to figure out B again? Well, we got this equation over here. 4B, we can plug 16 degrees in there, and we can figure it out pretty quick. So 58 plus 16, that's going to be a 74 degrees. Okay? And then we can kind of double check this. We know they're complementary. They should add to 90. So 16 and 74 do in fact get us 90. All right, and since this is simple angles, you could just leave it like this. So angle A is 16 degrees, angle B is 74 degrees. All right, and those are 90-degree complements. Okay, so for the second part of 6, I want you to give this a try. And then we will get to the homework. So, supplementary angles, angle A, angle B, those two are going to get us 180. And then it says B is 58 larger than angle A. So B is 58 larger than angle A, exactly the same equations as the other one. Take these, plug them into here, that whole list or whole equation. A plus 58 equals 180. We're just working with a larger number here now. 2A, not 8. A plus 58 equals 180. Minus the 58 again. 2A is equal to 122. A is going to be equal to 61 degrees. Okay? And then we need to take that, throw it into here. 61 plus 58, so angle B is equal to 119 degrees. Okay? And we'll put angles on there and call it a day. Okay? So we worked with changing words into an algebraic statement and writing clear answers. And we have completed our goals for the day. So if you need to replay it on anything on here, you can just go to YouTube, find the video, replay, go through some examples. It'll probably help you understand it a little bit better. So here is your homework for the day. And again, you'll have this on a worksheet. Let me know if you have any questions. Come tomorrow in class with questions. Thank you for watching.